Okay, so let's talk about logarithms. Maybe this is a word that you've heard before, but I'm guessing that most of you probably don't really know what it means in a math sense. So we're just going to kind of introduce what a logarithm is, what it means, and what it's used for. We're not going to do any really complicated problem solving with it today. So we're going to start with something that you are more familiar with, which is a root. So what a root does is it finds an unknown base. So let's see what that means a little bit. The square root of 64 is asking the question, we'll just use x for the unknown answer, what number times itself gives me 64? So this is kind of the solution to the equation. What number times itself would equal 64? And we could write this as x squared equals 64. Remember, if there's no number written on the root, it's a square root, so we could write a little 2 here. So a lot of times it's easy to think about this equation and what x should be to give us this answer in order to calculate the square root. What number times itself gives me 64? Maybe you already know that that is 8. So we say that the square root of 64 equals 8 because 8 times 8 would equal 64. And if we wanted to solve this equation for x, we could solve it by doing the square root of both sides. Okay, for an equation like this, 4th root of 16. I want to know what this equals. And to do that, I could use a calculator to just give me the answer, but I also could think about what that missing number should be. So x times x times x times x, the same number multiplied with itself 4 times, should equal 16. And I could write this equation as x to the 4th equals 16. So in this case, the x is acting as a base, meaning it's the thing that has an exponent. And we don't know what x is yet. So this is an unknown base. And you could just find this x by typing into your calculator 4th root of 16. Or you can try to think about what number actually works in this equation. What number times itself 4 times gives me 16. And that number is 2, because 2 times 2 is 4, times 2 again would be 8, and times 2 again would be 16. So to solve this equation, we would be doing the 4th root of both sides. It turns out that the 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. Okay. What about when we have a fraction like this? It still can work the same way. We want to think about what number times itself 3 times would give me this answer. So I could think about it as x times x times x should equal 1 over 125. And because this result is a fraction, this x should also be a fraction. And the thing that makes the most sense is 1/5 times 1/5 times 1/5 equals 1 over 125. So the cube root of 1 over 125 is 1/5. There we go. So if we had x cubed equals 1 over 125, we would solve that equation by doing the cube root of both sides. Notice the way that this layout is. This number, when we rewrite this as x cubed equals 1 over 125, this number becomes the exponent. This number becomes the sort of result of the exponent, and the base is the unknown. And the answer to the root is the unknown base. Okay. So let's look at this one. This number here is going to be our exponent. This number here is our sort of result of the exponent. And what this equals should be the unknown base. So, can we think of a number where we multiply the same number by itself 3 times and we get 10? Well, if I do 2 times 2 times 2, that would be 8. If I do 3 times 3 times 3, that would be 27. So we don't have a nice whole number that we can use to multiply by itself 3 times and equal 10. So we don't have a rational solution to this equation, but we know that it should be between 2 and 3. And so to solve this equation, we really just do need to type in the cube root of 10 into a calculator. So cube root of 10 equals 2.1544, etc. But this is the same relationship as it is with these other roots, just that we got an answer that is a long decimal. But we should still be able to put this answer in for x and get this equal to 10. So if I type this answer cubed, it should still equal 10, and it does. So this is still the solution to this equation. So hopefully this was a good review, kind of makes sense. What the answer to a root is telling you is the unknown base in an equation. So if you're not sure what the root answer should be and it comes out nice and even, you can often kind of rewrite it as an equation that looks like this, or an equation that looks like this, to help you understand what the root is doing. It's telling you what that unknown base is. There's another piece to the puzzle though, and that is when we want to find an unknown exponent. So just like a root finds an unknown base, a logarithm finds an unknown exponent. So the answer to a logarithm will be the missing exponent when you set it up in the equation. Just like the answer to the root is, or the answer to, the root is the missing base, the answer to the logarithm is an unknown exponent. So for example, if I have log base 8 of 64, this means I'm looking for a solution to the equation 8 to the x equals 64. So this number here is the base. In this case, we know it. The number inside is the result, and the answer to the log is the unknown exponent. So hopefully you can tell what number should go here to get 64 in the answer. and that number is 2. So we say that the log base 8 of 64 equals 2. And that's because when we set the problem up this way, we can see that that missing exponent should be 2 in order to make this equation work. Just like when we set up this same kind of problem with a root, we could tell that the number for x should be 8 to make the equation work. That made the answer 8. Here we're looking for the exponent instead. So we can tell that when we set up the equation this way, the exponent needs to be 2 for this equation to work. Let's try this one. So this is going to be the base. This is going to be the result of the exponent. And then the unknown exponent is going to be the answer. So let's say we could call this x. So 2 to the x equals 8. This became the base, this became the result. Whatever x comes out to be is going to be the answer to the log. So what number should be here in order to make this equation work? Well, 2 times 2 times 2 is 8. So I need 3 2's. So log base 2 of 8 is 3. I know this is kind of like thinking around it in a weird way, but you'll get used to it. Another way to help you rearrange these equations, if you like this way, then that's fine. But another way to kind of help you is if you write something like log base 2 of 8 equals x. You can take this little bottom number and kind of scooch it underneath and write it over here. And that gets rid of the log, and we get 8 equals 2 with an x above it. So if you kind of picture the 2 moving underneath here, we get 2 to the x on this side needs to equal 8, and then you can kind of tell what the x should be. Okay, this log is missing something. There's no number written on the bottom here. And that's because if there's nothing written, then the base is 10. So if there's no number written here, then you assume that the base is 10. This is still going to be the result. And then we'll put in an x for the unknown exponent. So 10 to the x needs to equal 0.01. Maybe this one is a little bit hard to see what it should equal, but we can rewrite this 0.01 as a fraction. And maybe that makes it a little bit easier to see that the exponent that we need here is -2, because 10 to the power of -2 would be 1 over 10 times 1 over 10, which would be 1 over 100. So this exponent should be -2, because 10 to the -2 is actually 1 over 100. And we can use the plain log button on a calculator to check this one, because it is the base 10 log. So I'm going to type in log of 0.01, and that is -2. Okay. If I wanted to solve this equation for x, maybe I would start by trying to figure out what power of x, or what power of 10 should be here to get exactly 250. But I know that 10 to the 2 is 100, and 10 to the 3 is 1,000. So that means that this x is not a whole number, and I probably can't just use the method of common bases like we did before to find it. So instead, I'm going to write this as a log. Now, this is the base. This is the unknown exponent. And this is the result. So I can kind of rearrange these elements into a new equation that has a logarithm. So I know that the base is supposed to go down here. The result is supposed to go inside. And then this will equal the unknown exponent. So I just took this equation and rewrote it like this. This is kind of the backwards of how we were doing it before, where we started with the log and we rewrote it with an equation that had x in the exponent. Now we did it in the opposite direction, where I started with an equation that has x in the exponent, and I rearranged it to write it as a logarithm so that the answer would just be x. And this is something that I'm going to need the calculator for because it doesn't come out to be a nice even whole number. So I'm going to type log. I don't need to type this little 10 because if there's nothing written there, it is 10 of 250. It's helpful to know that I'm expecting a number between 2 and 3, and I got 2.3979. So 2.3979 equals x. It goes on forever. It's an irrational number. But this is what I would need to put in the exponent to get exactly 250. So this is really what logs are used for, is solving equations that have a variable in the exponent when the numbers don't come out nice and even like they do for method of common basis problems. Let's see a little bit more about how to rearrange things into different formats. So kind of the easiest one to understand is probably this format where we have a base, an exponent, and we'll call this number the result. So we have our base, we have our exponent, and we have our result. We can arrange these three numbers in this way. And what this means is that if I do 2 times 2 times 2, I get 8. So I have 3 copies of a 2 multiplied together, and I get 8 as the result. I could write this same relationship 2 other ways. Because I have this rule for where things go in a root equation, and I also have rules for where things go in a log equation. So if I wanted to write this as a root, the way that a root goes is that it should be the exponent and then the result equals, and then the answer to the root is the base. So that's going to be 3 root result is 8 equals 2. So I basically took these same numbers and I moved them into new positions. But this is still true. It's still true that the cube root of 8 is 2. This is really still expressing the idea that 2 times 2 times 2 makes 8. I can also rearrange it the log way. Log, now the base goes down here. The result goes on the inside. And it equals the exponent. So log base 2, result thing was 8, equals 3. This is another way to write this relationship. And depending on which of these positions has the variable that you are looking for, you might want to write this same relationship in any of these 3 ways. You might want the exponent by itself. If you want the exponent by itself, you need to use the log format. You might want the base by itself. If you want the base by itself, you need to use the root format. Or you might want the result by itself, in which case you can just use the normal exponent format. Let's take another practice and rewrite this exponent format in the other two ways. So this is the base, this is the exponent, this is the result. So I could also write this as y root of a equals x, or I could also write this as log base x of a equals y. So I've put these same things in different spots according to kind of these rules. The exponent goes on the outside of the root, the result goes on the inside, and it equals the base. That's what I did here. Or if I want to write it with a logarithm, the base goes on the bottom, the result goes on the inside, and the exponent is the answer, like this. So this equation, and this equation all mean the same thing, just written in a different way with different parts of the equation by themselves. So if I was trying to find out what x equaled, I'd want to use this format. If I was trying to figure out what y equaled, I would want to use this format. Let's try converting this log format into the other ones. So I know this number down here is the base. This number here is supposed to be the result. And then this number is the exponent. So I could write this as 3 to the 4 equals 81. Base, exponent, result. Or I could write in the root format, the exponent goes first, the result goes on the inside, and the base goes is the answer. When I say result, I specifically mean the result when I just do the plain exponent kind. But this number really could be anywhere in the equation depending on which format you're using. So this equation, and this equation are all the same because each number is still in the correct spot. So this is where the base goes in a log, this is where the base goes when it's written like this, and this is where the base goes with a root. So each of the numbers is still in those correct spots for the base, the exponent, and the result. Okay, hope this was helpful. I hope that you got something out of it. This is probably about as far as we will go with logs. There's a lot of interesting other math applications to them. But for now, the main idea is that they let you solve equations where you have a variable in the exponent that you otherwise wouldn't be able to get by itself. Because the whole purpose of a log is that it gets the exponent by itself. All right. Hope that you are having a good day, and I will talk to you again soon. Bye.